Yeah. Because like now this class like counts like grade point average. So like I have to like
So I mean, I can tell you, we're going to have a quiz on Wednesday on whatever we actually cover today. That's why I wasn't going to say much about it, because I don't know what it's going to be on yet. Today's stuff. Just remind you guys also, and then we'll have another quiz sometime after that. We'll see. I'll know more tomorrow about if that will really be true or what's going to happen. So we'll talk more tomorrow about quizzes. The next test is next Tuesday. And then the final is next Thursday. You guys know that? Yeah. So, welcome to summer. Yes.
For the test 3, will we get our scores back the next day? Or?
Yes, you have to. So that day is already up. That's all I'm doing. Is Greg has something.
And then we'll have that one day if we can to correct the whatever.
Yeah, it's going to be. You'll have the opportunity. No matter how small it is, but what can I do? All right, so I couldn't find I know I made a handout at some point, but we will just do this thing. All right. So let's do this. All right. So, a couple things. What do you think about this? Not even telling you what the function is. If f of 2 is 7, you don't even know what the function is. What would f inverse of 7 have to be?
1/7.
So again, we've already forgotten. What does this notation... I'm sorry. What does this notation mean? That's the function that does the opposite of what this function does. So if this function is the add 5 function, for example, it doesn't have to be, but that is one function that would make this happen, isn't it? This function must be the... If this is the add 5 function, this must be the subtract 5 function. Is that what this function is? No, I'm not even thinking about that one, but that is an example of one that would do this. So no matter what the function is, I really want this to make sense. Whatever f does to 2, when I say that, does that make sense? If f is the add 5 function, then what does f do to 2? It adds 5 to 2. That's what the hell the function does, right? Whatever this function does to 2, to make it 7, this function is going to undo that. So it's always going to have to go back to 2. Now let me let that sink in. This is huge. This actually informs everything else we do with inverse functions. So it's kind of important. So really make sure this makes sense. Whatever function this is, it does something to 2 to make it 7. So what's the inverse function going to do? It's going to undo that thing to 7 to make it go back to 2. That's the whole idea of inverse function. Right? Yes, ma'am?
In a pair, or will it
No. This is an example of a question you could see, but I'm using it to motivate what we do visually and what we do algebraically. It's all based on this. And this is a great place to start because it's the whole idea of inverse function. So does that make sense? No? So, okay. So if my function was to rob you of money, right? So like, I see you, you have $10, and I take all that away. And then my brother is a cop, he's the inverse of me. So he's going to take you that currently has 0, and he's going to give back your $10. He's going to undo what I did. Whatever this did to 2 to make it 7, this is going to undo it to make it go back to 2. That's the basic idea of inverse function. So, for example, if the function was cube root of x, what would the inverse function be? X cubed. I like it. So what is f of 8? F of 8.
2.
Cube root of 8 is 2. And what is f inverse of 2? 8. Now I know, are you guys cool with that?
What?
What's f inverse of 2? So where do I put 2 then? Where do I put 2 into f inverse? And what does f inverse do to something?
Okay.
Cubes. I like it. So I know this is a specific function, but do you see how no matter what function I put here, as long as an inverse exists, and that's another thing, an inverse doesn't always exist. But as long as one exists, that has to be true. So I'm not telling you what the function is, but if f of 2 is 7, f inverse of 7 has to be 2. There's no other way around it. It'll undo what was done. I like it. And that's why I've said before that the cube root is the opposite function. So now we're being a little more technical. It's the inverse function of cube. Because it undoes what that cube does. All right. How are we doing? How are we feeling so far? Is that decent? So notice something about this statement. What is the 2 taking the place of? And what do I normally say? F of x. So 2 is like the x. It's the input. And 7 is the output. So when the inverse comes into play, what happens to the point? It gets switched. The input becomes the output, and the output becomes the input. Okay. So that's another level I can throw on top. I needed to make sure you guys understood and agreed with this. Now notice what that really means. So now I can talk visually what happens with inverses. I'm going to anyway. We'll see if I can. All right, here we go. So if I give you a picture of a function, and I have to be careful. We haven't talked about what it means to be an inverse. How do I tell if it has an inverse? And I can do it visually. So I have to be very careful when I create this. Not that careful, but if I'm not careful, then it's not going to have an inverse. Let me go up here. Sure. All right. So let's say I have this function here. Very kinky function. All right. Not a judgment. Just it's got kinks in it. What point is this?
2 minus 3. Negative 3.
I need to get there. And what point is this? And this is 1, 2, and this is
2, 4.
2, 4. All right, let me stop. So F, what does F do? F does this. F does this. Negative 2, negative 3, negative 1, 1, 1, 2, and 2, 4. Notice something about this function. What is a function? What did I have to be careful for it to not do? What is this function always doing? It's always going up. If it ever came back on itself, we got to figure out why that would not have an inverse. There would be no inverse. But watch this. Can you tell me where the output of 2 would come from? Where would the output of 2 come from? You can see it. What input would I have to do to make output 2? 1. Right? What's the input have to be for the output to be 2? 1. So if I had like a down parabola, right? Let's say right here for 1 and negative 1, it's here. You guys with me? So I'd say what input do I have to have an output of 2? Can you give me a singular answer? Or negative 1. See, so it comes back on itself. There's not a single answer for where an output of 2 came from. So that's why that actually wouldn't have an inverse. I can't undo it. So if I said, where did 2 come from? And you say, 1 and no, I need to know exactly where did 7 come from? It came from 2. So where did 7 come from? It came from 2. If there's multiple answers, it's not really an inverse function. All right, so we'll get there. Anyway, so what does the inverse function do? Let me see if you guys can take what we just talked about here. What really happens with the points? They just switch. And if I want to draw the inverse function, I just switch all those points. It almost seems too good to be true, but why does it make sense? Because whatever this function did to -2 to make it become -3, the inverse is going to take -3 and make it become -2 again. It's going to undo what it did. Hey, stop that. Leave him alone. Yeah. So this is whatever it did to -1 to make it 1, it's going to take 1 to make it go back to -1. 2, 1. 4, 2. And now plot those points. We'll see what the inverse function looks like. We don't even know what the hell these functions are, but I know what they look like. So 4, 2. So I need to make me a 4, 2. And a 2, 1. A 1, -1. And a -3, -2. All right, you guys with me? And then connect those dots. Do you notice anything interesting about symmetry? Where would you say the axis of symmetry would be here? Between these two. Do it in the air. What's it look like? Where's the mirror? Yeah, right here. And guess what this line is? This line is y equals x. So if I switch x and y, the visual flips over the y equals x line. Let that sink in for a minute. No matter what I do, no matter what function I would have made, it would have been symmetric like this. So if my function would look like that, the inverse would have looked like that. The mirror is at this line here. All right, let me let that sink in for a minute. It's kind of nifty. Again, I'm always like, am I the only one who believes that? I don't know. It's always possible. All right, so I know I've progressed past the basic idea, but everything I've done so far is based on whatever this does, this undoes it. That led us to this. We're here now. That's pretty far. All right, so what if I don't know what it looks like? What if I just am given a function and I need to find the opposite function? So what did I do here? Can somebody tell me very quickly, very precisely? If I'm given f, how do I graph f inverse? How could you tell me real quick what to do? Take all the f points and switch the
X, Y.
x and y. I love it. Now here's, and why does that make sense? Because of what we talked about here. Everything comes from this. All right. So algebraically, if I'm given a function, how do I find its inverse? I switch the x and y, and then I solve for y. So let's try that. Let's do a function that we know what the answer is going to be. So we kind of buy into the process, right? So what do I mean? I mean, for example, this is really, really easy. This is the first one we did. Let's say that f of x is the add 5 function. Now, if I start easy, I know the answer is easy. You don't have to do everything I'm about to do for this problem, but it's when the things get ugly. We can do the same thing we're about to do. First off, where's y?
No.
Where's y? There's x. Where's y? Yes, this took the place. So bring y back. All right. So have I really written it differently? No, it's just different notation for the same thing. Right, that's the output. That's the input. So let's just call it y like it was before. Now. This is almost too good to believe. Visually, I switch the x and y, regraph it. Algebraically, I switch the x and y, resolve it. So this is why I do this. I draw a little dotted line here because what I'm about to do is not algebraic, it's an idea. There's no way I can algebra the problem to look like this. I mean, that's breaking every damn rule there is. But I'm applying an idea. I'm not trying to find the function, I'm trying to find the inverse function. So how do I do that? I take this function and I make a new function where they're switched. Now solve for y and what do you get? Yes, ma'am?
When switching arms, isn't it supposed to be -5 instead of positive?
No. I'm not solving this. I'm not, how do I say this? So here, if you're completely cool with the fact that I just picked those up and turned them around, how algebraically, how did I make that happen? I applied an idea. The idea is the inverse function should make all the y's and x's switch. So the reason I draw this dotted line is to remind myself I'm not applying algebraic, solve an equation kind of steps. I'm applying an idea of how to get an inverse. That's why he draws a little line saying, what I'm about to do is based on an idea, not moving stuff around. I switch the x and y. Why? Because that's what the inverse function would do. It would switch x and y. And look how this makes sense. When I go to solve for y, I'm going to undo what's being done. So I'm going to do the opposite function. So of course I'm going to subtract 5, and I end up with that. And now what am I going to put in place of this?
F of x.
No, it's not f of x. What did I just find?
F of y.
The inverse.
Inverse. So I'm going to put f.
Of the negative 1.
So given the f of x, f inverse is that.
Well, it is not that.
See? Sorry?
It seems to the easy way because you just switch that from the beginning. We're already at x plus 5, so I'm just doing that.
I know. So again, like I said earlier, I start with a very simple example that you can do. You don't have to do it this way. Why do I do that? Because we already know what the answer is supposed to be. So any process I show you, better frickin' come up with the answer, or Jeff, screw your process, right? So it came up with what we knew the answer was supposed to be. So the process looks okay. All right, your process didn't screw shit up, Jeff. So did anybody? I wish I wouldn't have erased this. Did somebody write that ugly thing down I had up here that was a cube root? What was it? Cube root of 2x, right? Was it 2x?
No, the cube root of x.
It's just
and
x.
the inverse one was x cubed. That's it.
No. All right, you guys don't remember. I'll just make another one up. Plus
5.
5, sure. All right. Whatever it was, we'll just deal with this one. So, you cannot just look at that and tell me exactly what the inverse function is. I know you could hear. Why? Because there's one operation happening. Ooh. Here, there are many operations. So, this process will help me keep things organized. Right? So, what's the first step?
Y.
Bring y back. Right, Alex. By the way, can I make this 4?
No.
Of course I can't, because there's no negative 1 up there. There's a cube root of something with a minus 1 in it. There's no negative 1 up there.
So you can switch the y and x. Right?
Good. So I draw my little weird-ass line, Jeff, just to make myself feel better, that I'm not solving an equation right now. I am doing a step that will get me to be here, the inverse function. So this is a weird step. This is non-algebraic. It's just a concept. Switch x and y. All right. So not only does this make sense from the standpoint of everything we've done so far, but notice what happens when I go to solve. What do I always do when I solve an equation? I do the opposite function. So I do the opposite, don't I? So what am I going to do to get rid of this? All right. So see, it makes sense. I knew there was supposed to be a subtract 5 somewhere in the answer, because this function is adding 5. So you get x minus 5 equals the cube root. By the way, why did I do that first?
Because you want to get the radical.
Isolate the radical element and then kill it. All right. So now I can cube both sides. Please, dear God, there is no need to multiply this out. We're getting a function, and the function can be written like this. Subtract 5 from something and then cube it. You don't have to multiply that out. You with me? That's just extra steps. So that dies. So what do I have now? I have x minus 5 cubed.
2y.
Now just a couple more things and I'm done. Let me pull it up here. Yeah, so I'm here. Good, add 1. And then divide by 2. So I get, what's equal to this then? Good, F inverse. So that would have been G, this would have been G inverse. When you apply this process, you do not end up at the same function because of this weird thing you did here. You're going to get a brand new function based on what you did here. So let's see, why does this make sense? Because this multiplies by 2, this divides by 2. In fact, look at this. Some of you guys are going to notice, you could figure out how to do this without this process, but this process makes sure it comes out right. What's the first thing this does to x when I plug an x in? What's the very first thing you would do? If I plug a 7 in, multiply. What's the last thing this does?
Divide.
Divide by 2. What's the next thing this would do? Subtract 1. What's the next to the last thing this would do? Add 1, and so forth. You guys? So this process, when you solve an equation, you're doing all the opposite shit in the opposite order of the way it's done. So that's why it makes sense I would end up at a function that has all the opposite stuff in the opposite order. That's why this process makes sense. So let's try this out. Take a minute and figure out what is f of, you can do it. What's f of 14? What's f of 14? Don't say it out loud. Just take a second and figure out what that is. Do you see why I picked 14? Hopefully. Thanks. So what do you get? You double 14, you get 28 minus 1. Cube root of 27. Plus 5. 8. So what must f inverse of what be? I mean, what? Check it out. Make sure. Do f inverse of 8. Do it. I see you if you're not doing it. Draw a picture of a duck, and then I'll think you're doing it. Or do it. That's even better. Everybody with me what I'm asking you to do right now? I'm asking you what's f inverse of 8. Because we already know it should be 14 if we did all this shit right. Why should it be? Because that's what inverses do. That's where we started. That's what they should do. I like that. Some of you guys are doing it in your head. I can see that, so I appreciate that. There's no ducks. You're not. I don't know, you could be drawing a duck in your head. Okay. I mean, so you throw an 8 in. 8 minus 5 cubed
27.
plus 1
28.
divided by 2.
14.
Holy shit. So on one level, that should not be like a David Blaine moment. It's, of course it does that, because we just did everything in the opposite order. Of course that should take 8 and make it become 14. But that really hammers home, this is where I started, and now you can really see it in action. I mean, that's showing you this is what happens. All right, maybe. Okay. So here, you guys try this one. Find the inverse function for this. So let me catch up with you guys. What's the first step here? Bring y back. And then
Switch the X and Y.
switch the x and y. Well, if you do this for your pre-calc teacher and they have a problem with it, say, you're doing it wrong, but no, you understand? I screwed it. Now you start to solve. I like it. Multiply by 7. Add 5. Divide by 2. So now that is G inverse. So you can always check your work by, you can plug a specific number in here and then plug the result in there and make sure that it comes back. You could plug this entire function in there. Ooh, that sounds gross. Do it. See what you get. So what I'm asking you to do is this. What is G inverse of G of X? See what you get. Oh shit, there was a reason we talked about that shit earlier? Yes. So take, what does it say to do? Take G, plug it into G inverse. You must have faith. I used to have a teacher that would, I think he had a lot of hidden rage. If a student was sleeping in a class, everybody stared at him, no joke. He would chuck like pieces of chalk at him and just little chalk-sized bumps. All right. Sorry, buddy. How'd it come out? What'd you guys get? Yeah, think about it. What should, look at it from right here. What should this do to this? Cancel it. So you should expect to get X. Whatever G does to X, G inverse will undo it. You should get back to X. And that's how you check to make sure that you did your work right. So just to show you what this looks like. So it'd be G inverse of G. So I would take, what does G inverse do? It does 7 times something plus 5 over 2, and the something is all of this business. So what do you notice that's really, really nice? First right off the bat? Yeah. I mean, so no matter how ugly you think the work is going to be for that kind of problem, it's not. Because it's going to immediately start killing itself. It's going to be a lot easier than you think it's going to be. That dies. Then what happens?
The
5's die, and then the 2's die. I almost don't even have to rewrite this thing, hopefully. So you get X back. All right, some of you guys are like, I don't want my X back. I understand. Sorry. So, some of you guys might be like, yeah, please. I'm sorry. But anyways, that kind of thing should always happen. I mean, if you notice really quickly that it's not becoming pretty, then you must have done something wrong. Hopefully not here. Maybe over there you made something wrong. Okay, baby. How are y'all feeling? Does that jive with what we were saying earlier? Whatever it does to X, it undoes it. So having X in the end makes sense. That's a check to make sure I did the correct work.
So it's just X, that's it?
Totally. So let me ask you. What is the cube root of 2 cubed? Do I have a lot of work to do? Why? These cancel, so I get 2. So if G is like the cube and G inverse is like the cube root, then they should kill each other the same way. And you'll get X. So whatever G does to X, G inverse undoes it, so it comes back to X. So as long as you did the work right, that should always happen. And to be honest, it doesn't matter which way I do this. If it works one way, it's going to work the other way. Just like here, what is the cube root of 2 cubed? Same damn thing, who cares, right? So it doesn't matter which function you put into the other one, they are going to kill each other if you let them act on themselves, right? Okay, put them in the thing and just step back. All right. So, the main reason, math teachers kind of hate that we put, the books put this off until now. The reason the book did this now, we could have done this way back when we talked about functions. And it would have actually made a little more sense. But the reason we do it now is we're about to investigate a function that not everybody has seen. And the minute you learn a new function, you have to learn its opposite, its inverse. Why? Why would that have to be true? If you learn a new function, you must learn its inverse.
When you're doing square roots, you've got more than one answer.
Okay, you got to know how they act. But why must you know the inverse of some function? So here's a good example. If I did not know about,
Find the axis.
if I said, I want to say this. If you didn't know that division existed, but we talk about multiplication. That's a function. Multiply 7 by 2 is a function. And I said solve this.